Alright, hi year 12s, this is Mr. Lim here again, and this is going to be our third video on equilibrium expressions. Okay, so we're going to be learning about equilibrium expressions, describing what they are and what information it tells us. Okay, cool. So let's just go through again. Equilibrium is when you have dynamic equilibrium, where you've got the same number of reactants and products being made at any given point because the forward and reverse reactions are going at the same rate. Okay. And so for different reactions, there are going to be different amounts of reactants and products that are there when they're going at the same rate. So some reactions will have a lot of products, some reactions will have a lot of reactants. Okay, so uh, therefore this equilibrium constant is effectively the ratio of products to reactants at equilibrium at certain temperatures for a certain reaction. Okay, so it's just like saying it's a value to use to compare different equilibrium systems and then give them information about the reactants and the products. Okay, so the idea is that each reaction is different. When reaction 1 is at equilibrium, it's going to have a different ratio of products to reactants than at reaction number 2, and so therefore we need a way to compare them. Okay, so the way we compare them is to create this equilibrium constant, which is a number that we can compare. All right, so what we do is we take the balanced equation and we take their coefficients, that's these ones here, okay, of the various substances, and we take the concentration, so that's what these square brackets means, the concentration, right? And so we take the concentration of the products over the reactants, and then we apply the power of the coefficients to each of them. Okay, so the concentration in mole per liter, in mole per liter, right? And then we apply the power of the coefficient to that concentration in moles per liter, and then we take all the products and multiply them to each other to the product of the products, and then the product of the reactants, product being the multiplication of. All right, so when we put that into an equation, we get a number, and that is equal to the that's not what I wanted. The equilibrium constant for that reaction, also known as the K value for that reaction at a particular temperature. All right, so it's just a value of products to reactants. Okay, so equilibrium constant expressions, you only have aqueous and gas substances go into this equilibrium constant expression, okay? Because those are the substances that can have a concentration, okay? Solids and liquids kind of concentrations. So if, say, let's just say A was a solid, right? Then we wouldn't have A in that equation, okay? But if B is an aqueous substance, then yes, we would have that in the equation. All right, so we only have aqueous and gases in equilibrium constants expressions. All right, so we can practice this with a couple of equilibrium constant expressions. I'll let you have a go at them. Okay, I'll just do the first one quickly here. Right, K is equal to products over reactants. Okay, so I have taken the coefficients here and here and applied them here and here. All right, so it'd be the concentration of the O2 to the power of 3 over the concentration of the O3 to the power of 2. Okay, and then you have a go at these ones later on. Okay, so what does this information give us? So it effectively gives us information about the reaction and how the concentration of products compares to the concentration of reactants. So how the concentration of products compares to the concentration of reactants. Okay, so a high K means that the products are present in a much higher concentration than the reactant. So effectively, it's all products. Okay, so all products. Therefore, the reaction goes to completion. And what does that mean? The reaction goes to completion. There's almost no reactants left. There's only products left. Okay, so no reactants. A low K value whoops, a low K value, right, means that the reactants are present in a much higher concentration than the products. Okay, so effectively you have lots and lots of reactants. The lower the K value is, the more likely that the reaction does not even occur. Okay, so it just has so high a forward activation energy that the reaction just doesn't occur, and so therefore you've just got a very, very low K, meaning you've got lots of reactants and not many products. Okay, and if that's like typical of things that need a large activation energy to occur, but then as you change the temperature, you'll change whether that reaction is likely to occur or not. Okay, and so we'll talk about that later on. Okay, comparing K values, you can give you information about which of the two reactants produces more products and reactants, and if they have the same reactants and products, like hydronium ions, you can make further inferences like the pH and stuff like that. So if I have reaction number 1, which has a K value of, like 100, and I have reaction number 2, which has a K value of like 4, therefore I can say that this one here, reaction number 1, has many more products than reaction number 2. Okay, and if one of those products happens to be a hydronium ion or a hydrogen ion, we could say that that this is more acidic, assuming that both of them have H3O plus ions in their reactions. Okay. Then temperature can change equilibrium constants. The value of K can change with the change in temperature. The change in temperature will affect the amount of energy, because the value of K changes with changes in temperature, changes the amount of energy each particle has, right? And so therefore the proportion of reactants that have sufficient energy. Okay. Depending on the difference in activation energies, this means a higher concentration of reactants or products is formed. I guess the best example of this would be a combustion reaction, where if you bring the temperature high, well, if you have the temperature low enough, there's not enough energy, so you have lots of reactants and no products. If you have a much higher temperature, the reaction occurs and then it doesn't go backwards, so therefore it's just going to have lots of products and almost no reactants. Even though it's the same reaction at different temperatures, you're going to have a very different K value. All right, and that's it for equilibrium constant. We'll go talk about the reaction quotient, which is very similar, next time. Adios.